did not take long before the scientists began to notice that complex systems showed certain common behaviors. They started to think of these behaviors as characteristic of all complex systems. They realized that these behaviors could not be explained by analyzing the components of the system. The time-honored scientific approach of reductionism, taking the watch apart to see how it worked, didn't get you anywhere with complex systems, because the interesting behavior seemed to arise from the spontaneous interaction of the components. The behavior wasn't planned or directed, it just happened. Such behavior was therefore called self-organizing. Of the self-organizing behaviors, two are of particular interest to the study of evolution. One is adaptation. We see it everywhere. Corporations adapt to the marketplace. Brain cells adapt to signal traffic. The immune system adapts to infection. Animals adapt to their food supply. We have come to think that the ability to adapt is characteristic of complex systems, and may be one reason why evolution seems to lead toward more complex organisms. But even more important is the way complex systems seem to strike a balance between the need for order and the imperative to change. Complex systems tend to locate themselves at the place we call the edge of chaos. We imagine the edge of chaos as a place where there is enough innovation to keep a living system vibrant, and enough stability to keep it from collapsing into anarchy. It is a zone of conflict and upheaval, where the old and new are constantly at war. Finding the balance point must be a delicate matter. If a living system drifts too close, it risks falling over into incoherence and dissolution. But if the system moves too far away from the edge, it becomes rigid, frozen, totalitarian. Both conditions lead to extinction. Too much change is as destructive as too little. Only at the edge of chaos can complex systems flourish. From Malcolm's point of view, there had been only predictable objections, that mass extinctions were important. The human beings owed their existence to the Cretaceous extinction, which had wiped out the dinosaurs and allowed the mammals to take over. As one questioner had pompously phrased it, the Cretaceous allowed our own sentient awareness to arise on the planet. Malcolm's reply was immediate. What makes you think human beings are sentient and aware? There's no evidence for it. Human beings never think for themselves. They find it too uncomfortable. For the most part, members of our species simply repeat what they are told and become upset if they are exposed to any different view. The characteristic human trait is not awareness, but conformity, and the characteristic result is religious warfare. Other animals fight for territory or food, but uniquely in the animal kingdom, human beings fight for their beliefs. The reason is that beliefs guide behavior, which has evolutionary importance among human beings. But at a time when our behavior may well lead us to extinction, I see no reason to assume we have any awareness at all. We are stubborn, self-destructive conformists. Any other view of our species is just a self-congratulatory delusion.
You know what I heard? I've heard that a couple years back, a company named InGen genetically engineered some dinosaurs and put them on an island in Costa Rica. But something went wrong. A lot of people were killed, and the dinosaurs were destroyed. And now nobody will talk about it because of some legal angle, non-disclosure agreements or something. And the Costa Rican government doesn't want to hurt tourism, so nobody will talk. That's what I've heard.
And you believe that?
Not at first, I didn't. But the thing is, I keep hearing it. The rumors keep floating around. Supposedly, you and Alan Grant and a bunch of other people were there.
Did you ask Grant about it?
I asked him last year at a conference in Peking. He said it was absurd. Is that what you say? I mean, you know Grant, don't you?
No, I never met him.
So, it's not true.
Are you familiar with the concept of a Techno-Myth? It was developed by Geller at Princeton. Basic thesis is that we've lost all the old myths, Orpheus and Eurydice and Perseus and Medusa. So we fill the gap with modern techno-myths. Geller listed a dozen or so. One is that an alien's living at a hangar at Wright-Patterson Air Force Base. Another is that somebody invented a carburetor that gets 150 miles to the gallon. but the automobile companies bought out the patent and are sitting on it. Then there's the story that Russians trained children in ESP at a secret base in Siberia, and these kids can kill people anywhere in the world with their thoughts. The story that the lines in Nazca, Peru are an alien spaceport, that the CIA released the AIDS virus to kill homosexuals, that Nikola Tesla discovered an incredible energy source, but his notes are lost, that in Istanbul there is a 10th century drawing that shows the Earth from space, that the Stanford Research Institute found a guy whose body glows in the dark. Get the picture? Colleagues who knew Jack Thorne agreed that retirement marked the happiest period of his life. As a professor of applied engineering and a specialist in exotic materials, he had always demonstrated a practical focus and a love of students. His most famous course at Stanford Structural Engineering 101A was known among the students as Thorny Problems, because Thorne continually provoked his class to solve applied engineering challenges he had set for them. Some of these had long since entered into the student folklore. There was, for example, the toilet paper disaster. Thorne asked the students to drop a carton of eggs from the Hoover Tower without injury. As padding, they could only use the cardboard tubes at the center of toilet paper rolls. There were spattered eggs all over the plaza below. Then, another year, Thorne asked the students to build a chair to support a 200-pound man using only paper Q-tips and thread. And another time, he hung the answer sheet for the final exam from the classroom ceiling and invited his students to pull it down using whatever they could make with a cardboard shoebox containing a pound of licorice and some toothpicks. When he was not in class, Thorne often served as an expert witness in legal cases involving materials engineering. He specialized in explosions, crashed planes, collapsed buildings, and other disasters. These forays into the real world sharpened his view that scientists needed the widest possible education. He used to say, "How can you design for people if you don't know history and psychology? You can't, because your mathematical formulas may be perfect, but the people will screw it up. And if that happens, it means you screwed it up." He peppered his lectures with quotations from Plato, Shaka Zulu, Emerson, and Chuang Tzu. But as a professor who was popular with his students and who had advocated general education, Thorne found himself swimming against the tide. The academic world was marching toward ever more specialized knowledge, expressed in ever more dense jargon. In this climate, being liked by your students was a sign of shallowness. An interest in real-world problems was proof of intellectual poverty, and a distressing indifference to theory. But in the end, it was his fondness for Chuang Tzu that pushed him out the door. In a departmental meeting, one of his colleagues got up and announced that
some mythical Chinese bullshitter means fuck all for engineering.
Thorne took early retirement a month later, and soon after started his own company. He enjoyed his work thoroughly, but he missed contact with the students, which was why he liked Lavine's 2 youthful assistants. These kids were smart, they were enthusiastic, and they were young enough so that the schools hadn't destroyed all their interest in learning. They could still actually use their brains, which in Thorne's view was a sure sign they hadn't completed a formal education. All extinction theories are based on the fossil record, but the fossil record doesn't show the sorts of behavior we're seeing here. It doesn't record the complexity of groups interacting, and bones are not behavior. When you think about it, the fossil record is like a series of photographs, frozen moments from what's really a moving, ongoing reality. Looking at the fossil record is like thumbing through a family photo album. You know that the album isn't complete. You know that life happens between the pictures, but you don't have any record of what happens in between. You only have the pictures, so you study them, and pretty soon you begin to think of the album not as a series of moments, but as reality itself. And you begin to explain everything in terms of the album, and you forget the underlying reality. And the tendency has been to think in terms of physical events, to assume that some external physical event caused the extinctions. A meteor hits the Earth and changes the weather, or volcanoes erupt and change the weather, or a meteor causes the volcano to erupt and change the weather, or vegetation changes and species starve and become extinct, or new diseases arise and species become extinct, or a new plant arises and poisons all the dinosaurs, In every case, what is imagined is some external event, but what nobody imagines is that the animals themselves might have changed, not in their bones, but in their behavior. When you look at animals like these and see how intricately their behavior is interrelated, you realize that a change in group behavior could easily lead to extinction.
But why would group behavior change if there wasn't some external catastrophe to force it? Why should the behavior change?
Actually, behavior is always changing, all the time. Our planet is a dynamic, active environment. Weather is changing. The land is changing. Continents drift. Oceans rise and fall. Mountains thrust up and erode away. All the organisms on the planet are constantly adapting to those changes. The best organisms are the ones that can adapt most rapidly. That's why it's hard to see how a catastrophe that produces a large change could cause extinction, since so much change is occurring all the time anyway.
In that case, what causes extinction?
Certainly not rapid change alone. The facts tell us that clearly.
What facts?
After every major environmental change, a wave of extinction has usually followed, but not right away. Extinctions only occur thousands or millions of years later. Take the last glaciation in North America. The glaciers descended. The climate changed severely, but animals didn't die. Only after the glaciers receded, when you'd think things would go back to normal, did lots of species become extinct. That's when giraffes and tigers and mammoths vanished on this continent. And that's the usual pattern. It's almost as if species are weakened by major change, but die off later. It's a well-recognized phenomenon.
It's called softening up the beachhead.
And what's the explanation for it? There is none. It's a paleontological mystery. But I believe that complexity theory has a lot to tell us about it, because if the notion of life at the edge of chaos is true, then major change pushes animals closer to the edge. It destabilizes all sorts of behavior. And when the environment goes back to normal, it's not really a return to normal. In evolutionary terms, it's another big change, and it's just too much to keep up with. I believe that new behavior in populations can emerge in unexpected ways. About 3 million years ago, some African apes that had been living in trees came down to the ground. There was nothing special about these apes. Their brains were small, and they weren't especially smart. They didn't have claws or sharp teeth for weapons. They weren't particularly strong or fast. They were certainly no match for a leopard. But because they were short, they started standing upright on their hind legs to see over the tall African grass. And that's how it began. Just some ordinary apes looking out over the grass. As time went on, the apes stood upright more and more of the time. That left their hands free to do things. Like all apes, they were tool users. Chimps, for example, used twigs to fish for termites. That sort of thing. As time went on, our ape ancestors developed more complex tools. That stimulated their brains to grow in size and complexity. It began a spiral. More complex tools provoked more complex brains, which provoked more complex tools. And our brains literally exploded, in evolutionary terms. Our brains more than doubled in size in about 1 million years, and that caused problems for us.
Like what?
Like getting born, for one thing. Big brains can't pass through the birth canal, which means that both mother and child die in childbirth. That's not good. What's the evolutionary response? To make human infants born very early in development, when their brains are still small enough to pass through the pelvis. It's the marsupial solution. Most of the growth occurs outside the mother's body. A human child's brain doubles during the first year of life. That's a good solution to the problem of birth. But it creates other problems. It means that human children will be helpless long after birth. The infants of many mammals can walk minutes after they are born. Others walk in a few days or weeks. But human infants can't walk for a full year. They can't feed themselves for even longer. So one price of big brains was that our ancestors had to evolve new, stable social organizations to permit long-term child care, lasting many years. These big-brained, totally helpless children changed society. But that's not the most important consequence. Being born in an immature state means that human infants have unformed brains. They don't arrive with a lot of built-in instinctive behavior. Instinctively, a newborn infant can suck and grasp, but that's about all. Complex human behavior is not instinctive at all, so human societies had to develop education to train the brains of their children, to teach them how to act. Every human society expends tremendous time and energy teaching its children the right way to behave. You look at a simpler society in the rainforest somewhere, and you find that every child is born into a network of adults responsible for helping to raise the child. Not only parents, but aunts and uncles, and grandparents and tribal elders. Some teach the child to hunt or gather food or weave. Some teach them about sex or war. But the responsibilities are clearly defined. If a child does not have, say, a mother's brother's sister to do a specific teaching job, the people get together and appoint a substitute. Because raising children is, in a sense, the reason the society exists in the first place. It's the most important thing that happens, and it's the culmination of all the tools and language and social structure that has evolved. And eventually, a few million years later, we have kids using computers. Now, if this picture makes sense, where does natural selection act? Does it act on the body, enlarging the brain? Does it act on the developmental sequence, pushing the kids out early? Does it act on social behavior, provoking cooperation and child caring? Or does it act everywhere all at once, on bodies, on development, and on social behavior?
Everywhere at once.
I think so, but there may also be parts of this story that happen automatically, the result of self-organization. For example, infants of all species have a characteristic appearance: big eyes, big heads, small faces, uncoordinated movements. That's true of kids and puppies and baby birds. And it seems to provoke adults of all species to act tenderly toward them. In a sense, you might say infant appearance seems to self-organize adult behavior, and in our case, a good thing too.
What does that have to do with dinosaur extinction?
Self-organizing principles can act for better or worse, just as self-organization can coordinate change. It can also lead a population into decline and cause it to lose its edge. On this island, my hope is we'll see self-organizing adaptations in the behavior of real dinosaurs, and it'll tell us why they became extinct. In fact, I'm pretty sure we already know why the dinosaurs became extinct. Changes can occur very quickly. Human beings are transforming the planet, and nobody knows whether it's a dangerous development or not. So these behavioral processes can happen faster than we usually think evolution occurs. In 10,000 years, human beings have gone from hunting to farming to cities to cyberspace. Behavior is screaming forward, and it might be non-adaptive. Nobody knows. Although personally, I think cyberspace means the end of our species, because it means the end of innovation. This idea that the whole world is wired together is mass death. Every biologist knows that small groups in isolation evolve fastest. You put 1,000 birds on an ocean island, and they'll evolve very fast. You put 10,000 on a big continent, and their evolution slows down. Now, for our own species, evolution occurs mostly through our behavior. We innovate new behavior to adapt. And everybody on Earth knows that innovation only occurs in small groups. Put 3 people on a committee, and they may get something done. 10 people, and it gets harder. 30 people, and nothing happens. 30 million, it becomes impossible. That's the effect of mass media. It keeps anything from happening. Mass media swamps diversity. It makes every place the same. Bangkok or Tokyo or London. There's a McDonald's on one corner, a Benetton on another, a Gap across the street. Regional differences vanish. All differences vanish. In a mass media world, there is less of everything except the top 10 books, records, movies, and ideas. People worry about losing species diversity in the rainforest. But what about intellectual diversity, our most necessary resource? That's disappearing faster than the trees. But we haven't figured that out, so now we're planning to put 5 billion people together in cyberspace. And it'll freeze the entire species. Everything will stop dead in its tracks. Everyone will think the same thing at the same time. Global uniformity. In darkness, Malcolm sank back into morphine dreams. Images floated in front of his eyes. Fitness landscapes, the multicolored computer images now employed to think about evolution. In this mathematical world of peaks and valleys, populations of organisms were seen to climb the fitness peaks or slide down the valleys of non-adaptation. Stu Kaufman and his coworkers had shown that advanced organisms had complex internal constraints which made them more likely to fall off the fitness optima and descend into the valleys. Yet at the same time, complex creatures were themselves selected by evolution because complex creatures were able to adapt on their own, with tools, with learning, with cooperation. But complex animals had obtained their adaptive flexibility at some cost. They had traded one dependency for another. It was no longer necessary to change their bodies to adapt, because now their adaptation was behavior, socially determined. That behavior required learning. In a sense, among higher animals' adaptive fitness, it was no longer transmitted to the next generation by DNA at all. It was now carried by teaching. Chimpanzees taught their young to collect termites with a stick. Such actions implied at least the rudiments of culture, a structured social life. But animals raised in isolation, without parents, without guidance, were not fully functional. Zoo animals frequently could not care for their offspring because they had never seen it done. They would ignore their infants, or roll over and crush them, or simply become annoyed with them and kill them. The velociraptors were among the most intelligent dinosaurs, and the most ferocious. Both traits demanded behavioral control millions of years ago in the now vanished Jurassic world. Their behavior would have been socially determined, passed on from older to younger animals. Genes controlled the capacity to make such patterns, but not the patterns themselves. Adaptive behavior was a kind of morality. It was behavior that had evolved over many generations because it was found to succeed. Behavior that allowed members of the species to cooperate, to live together, to hunt, to raise young. But on this island, the velociraptors had been recreated in a genetics laboratory. Although their physical bodies were genetically determined, their behavior was not. These newly created raptors came into the world with no older animals to guide them, to show them proper raptor behavior. They were on their own, and that's just how they behave. In a society without structure, without rules, without cooperation, they lived in an uncontrolled, every creature for himself world, where the meanest and the nastiest survived, and all the others died. If you haven't already, please consider buying a Stars and Stripes Freedom deck. I designed these myself, and it supports the work I do.